Okay, so for this video, we are going to see mutually exclusive event, independent event, and also conditional event. So as you can see, for these three events, we have different purpose and we have different formulas. So as you can see from mutually exclusive event, and the definition is this one is supposed to be cannot occur at the same time. Okay, make sure you betulkan. This one cannot occur, two events cannot occur at the same time. And for independent event, one event does not affect another outcome of the event. And for conditional event, normally in the question will say something about if, knowing, given. Okay, so we are going to look at each of these different event later on. Okay, so here let's start with mutually exclusive event. So what is mutually exclusive? Two events A and B are called mutually exclusive if they cannot occur at the same time. So cannot occur at the same time. So what can you conclude if the two events cannot occur at the same time? There is no intersection. Okay, no intersection between between A and B. Therefore, A intersect B is equals to 0. Okay, there is no intersection. That means your probability of A intersect B is equals to 0. If we represent that in Venn diagram, it will be looking something like this. Okay, one circle, another one circle. Okay, so there is no A intersect B. So therefore, if A and B are mutually exclusive, then if we use the formula for PA union B, A or B or both, we have PA plus PB minus PA intersect B. Since PA intersect B is equals to 0 if event A and event B are mutually exclusive, therefore you are left with only PA plus PB. Okay, I repeat. So the formula, if mutually exclusive, we have PA union B is equals to PA plus PB. So that is your formula for mutually exclusive event. So examples for mutually exclusive event, let's say if we have event rolling a dice once. Okay, rolling a dice once, which is you will get 1, 2, 3, 4, 5. So let's say event A is an odd number, which is we have 1, 3, 5, and event B is an even number, which is you'll get outcomes 2, 4, 6. So as you can see from here, event A and event B cannot occur at the same times. Obviously, if you roll a dice once, you cannot get the two numbers, odd and even numbers. So that is what we call as mutually exclusive. Okay, the two events cannot occur at the same time. So therefore, A intersect B is equals to 0. Okay, so let's see example 12. We have a bag contains 4 red marbles, 2 white marbles, 8 black marbles. What is the probability that a marble picked from the bag at random is either red or white? So you know red or white. Okay, so you know that either or, we represent it as PR union W. Okay, either A or B or both is PA union B. So the same thing as red and white here. So this is a mutually exclusive event. So we are going to use PR plus PW only, which is we're supposed to minus PR intersect W, since PR intersect W is equals to 0 because it cannot happen. So we are going to do this only. So probability of we pick R will be R is 4. Okay, the total number of marbles in the bag is 14, so you'll get 4 over 14 plus white is 2 over 14, and we have the answer 3 over 7. Okay, so we have 4 red, 2 white, 8 black, so therefore we have 14 marbles. Okay, so that is your number of sample space. Okay, let's see example 13. One student feels that the probability he will get a grade D in a statistic course is 1 over 8. Okay, so let's write that as PD equals to 1 over 8. And the probability that he will fail or grade worse than D is 1 over 16. Okay, so let's write that as P fail. equals to 1 over 16. Obviously, the two events cannot occur at the same time. If the student get grade D, obviously he will not fail. Okay, if the student get if the student fail, obviously he will not get grade D. Okay, so this is a mutually exclusive event. Sometimes the question will tell you that it is a mutually exclusive event. So what we want here is, what is the probability that he will get a grade better than D? Grade better than D. So what does it mean by that? Grade better than D. So that means not fail, not D. Maybe dia akan dapat A, B, C, C plus, C minus. So that means this one is neither D nor fail. Okay, better than D. Obviously better than D bukan fail lah kan. So that will be neither D nor F. So how are we going to put neither nor into our formula, or this one here? Neither nor D union F prime. Okay, if either or, this without this one, if neither nor with this one here. Okay, I want to put it one more time. Either or, let's put that in different color. If the question said either or is PA union B, if the question said neither nor, that is PA union B prime. Okay, so make sure you understand that both of that thing. So now back to the question, we have PD union F prime. So how are we going to change this one here? We have 1 minus PD union F. Okay, so 1 minus, so this is what we are going to do. PD union F is, we are going to use the formula for mutually exclusive. So only PD plus PF, because the D intersect F is equals to 0, okay, which cannot happen. So we have 1 minus PD is 1 over 8, PF is 1 over 16, then we'll get 13 over 16. Okay, so that is our answer. Alright, so let's see example 14. The results of the final exam in a college who took both biology and mathematics papers are as follows. We have 600 students pass the biology papers, 300 students pass the mathematics. So from at one look, how are you going to represent the data that you have here? Okay, the easiest way. So as I said, you can use tree diagram, you can use table, and one more thing is you can use the Venn diagram, and you can also use table for this type of question. Okay, you can try whatever suits you, but for now let's just use Venn diagram. So we have for biology and also mathematics, and remember this is past the paper. Okay, what we are going to use here, the Venn diagram, is for the student that passed the papers. Okay, so here we have 600 students pass biology, 300 students pass mathematics, and 175 students pass both papers. So that is what you are going to write first. 175 in the middle. Okay, 175 in the middle. Let's just change this quickly. Alright, so 175 in the middle. Okay, so now this is biology, this is mathematics. Pass biology, pass mathematics. So since 600 students pass biology, so 600 is included, 175 is included with the 600 here. So what you're going to do is you're going to minus 600 minus 175. You have 425 student passed only biology. Okay, so 300 student passed mathematics. So 300 minus 175, we have 125 only pass mathematics. So you have how many students do we have? 50 students fail both papers. Okay, so this is for pass. So if the student fail, let's put them outside here. Okay, 50 students fail. Okay, now from the information above, calculate how many of the college students took mathematics and biology papers. So this question is very tricky because it doesn't say pass the paper. Okay, the question literally said took the mathematics and biology paper. So doesn't matter if you fail or you pass the paper. So took biology and maths papers. So what we are going to do is we are going to sum up all the students. Okay, one more time. The question said how many of the college students took the mathematics and biology paper. Took. Okay, so it doesn't matter you pass or you fail, everything is considered. So what we are going to do is we are going to sum up all the students for 25, 175, 125, 50. And the question doesn't say something about probability, just want to know the number. So just let's put that as number of student. Number of students took maths and bio is equals to 425 plus 175 plus 125 plus 50, which is we have 775 students. Okay, fail and pass all considered. B, the probability of a student chosen at random who pass both paper. Okay, pass both paper, what does it mean by that? We have P B intersect M. Okay, PB intersect M. So obviously we have at the center here equals to 175. Don't forget to over by the total sample space, which is we have from A 775. Okay, so that's it. Just leave it like that. Or we can simplify 7/31. Okay, so now let's see last question here. Find the probability of a student chosen at random who did not pass in mathematics. Did not pass in mathematics, which is PM prime. Okay, did not pass in mathematics. So you know that formula for PM prime is equals to 1 minus PM. So what you are going to find here is probability of M. So probability of M is all of this here. Okay, all of this here. So 125 plus 175 is 300, which is the same thing as here. So we have 1 minus 300 over 775 equals to 19/31. Okay. So now for this question, you can try it by yourself. So a dice is tossed twice. A dice is tossed twice. So what you are going to do is the same thing as the previous video. We have to do this thing here. So it's easy to find whatever the question want. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, what the question want? Question said A is the event, the sum of two numbers uppermost is greater than 5, and the second event is the sum of two numbers uppermost is less than 8. So the question want the sum. So you just sum up all this thing here and find all the probability that you have here. Okay, please find it by yourself. I just give you the final answer. So this one is 13/18, 7/12, 11/36. This one is 1. Okay, you tell me the answer. A and B are mutually exclusive. Okay, next part we're going to see conditional probability and independent events. So we are going to see conditional events first. So what is a conditional event? When an event happens, is considered with the condition that another event has occurred. Or what we're going to find is actually the probability that probability of event will occur given that another event has occurred. Okay, another event has occurred. Okay, some of the keyword for this conditional event, how are we going to know that we are going to find conditional probability? So some of the keywords are knowing that, or sometimes the question said if, or sometimes the question said given that. Okay, so that are the keyword to know that we are going to find the conditional probability. So these are the examples of a conditional event. The event that a girl is chosen knowing that the student wears spectacles. Okay, so the same thing as the second one here. So let's just go straight to the formula. So how are we going to find the probability of a conditional probability? So here we have probability of A given B. So what you are going to do is, if you have given B or given A, so these are the event that has occurred. Okay, already happened. Both of these already happened. So selepas perkataan given, that means that event already occurred. So what you are going to do is, this is what the formula, PA given B. This palang dekat sini, dash dekat sini represent given that. Okay, ini represent that given that. Okay, so that means if you want to find probability of A, probability of A given B, let's just get rid of this first. Given is the palang there, B. Okay, that's it. So probability of B given so given is the palang there, A. Okay, so yang given kena berada di belakang, yang di depan is A. Okay, whenever, sometimes the question said given B, find the probability of A. So given B has to be on the behind. Okay, so whenever you see given something, given the event has to be at the back. So the formula for PA given B is PA intersect B over PB. Okay, so this thing here has to be the same. Okay, so this one PA, this one PA, this one PB, this one PB. So the same thing as PB given A, PB intersect A over PA. So let's see the example 16. Event A and B are such that PA equals to 1 over 4, PB equals to 1 over 3, and we have PA union B. So the question asks to find PA intersect B. We don't know how to find PA intersect B. We only know how to find PA union B, which is the formula is PA plus PB minus PA intersect B. So as you can see from the question, we have PA union B, we have PA, we also have PB, and we want to find this here. So we just rearrange. So PA union B is 5 over 12. Here PA is 1 over 4. PB is 1 over 3 minus PA intersect B. So rearrange everything, you will get PA intersect B is equals to 1 over 6. Okay, so now to find PB given A. So PB given A, the formula is PB intersect A. Just follow the arrangement. Okay, just follow the order. PB intersect A over, yang di bawah mesti sama dengan yang di belakang. So PB intersect A over PA. So B intersect A is the same as PA intersect B. Okay, so that will be 1 over 6 from question A. So PA is given in the question, so we have over 1 over 4, and that will be 2 over 3. Okay, so now let's go to example 17. PA given to us PA, PB and PA union B. So want to find PA intersect B, the same thing as before. We only know the formula for PA union B, which is PA plus PB minus PA intersect B. So we just substitute what we have. 1 over 2 equals to PA is 1 over 3, PB is 1 over 4, and this is what we want to find, PA intersect B. So rearrange everything, you should get PA intersect B is equals to 1 over 12. Okay, now PA intersect B prime. Do we have the formula for this? Yes, we do. PA intersect B prime is for only A occurs, which is PA only minus PA intersect B. Okay, so we have PA, which is 1 over 3. This one we have from question A, which is 1 over 12. So here the answer is 1 over 4. Okay, PB given A. PB given A, so we just simply follow the order. PB intersect A. So what will be down here is the same thing on the back, PA. Okay, so PB intersect A is the same as PA intersect B, which is 1 over 12. PA given in the question, which is 1 over 3. And we'll have the answer 1 over 4. Okay. Alright, so here we have the last one. PA given B prime. So just follow the order. PA intersect B prime. Below here is what is in the back. PB prime. So PA intersect B prime. How are we going to get that? From question B. We have that in question B, 1 over 4. And PB prime, we have PB. Okay, we have PB. So you should know your PB prime, which is 1 minus 1 over 4. So here we have 1 over 3. Okay, the last one. The probability that exactly one of A or B will occur. So focus on or here. Exactly one of A, that means only A or B will occur. So exactly 1A is PA intersect B prime. Okay. Only B is PB prime, or we can just write as PA prime intersect B. So or is plus. Okay. So PA intersect B prime, from question B we have 1 over 4. A intersect A prime intersect B. Just use the formula. We have PB minus PA intersect B. Okay, substitute everything. You should get 1 over 4 plus 1 over 4 minus 1 over 12. And here's the answer is 5 over 12. Okay, so that's it for conditional probability only by using formula. So now next example, we are going to see the problem statement here. We have in a college, 12% of the students are left-handed. Okay, left-handed. So let's represent this as L. And 15 of the students are curly-haired. Curly-haired. So that will be C. Okay. And 3% are both left-handed and curly-haired. So let's put everything together. PL is equals to 12%. So that will be 0.12. Curly-haired, probability of curly-haired is 0.15. So this one here, this thing here, both left-handed and curly-haired is actually your P left-handed intersect curly-haired, which is we have 0.03. Okay, so that is what we have from the question. So first one, given that a student curly-haired, okay, given that, here we have given that, given C. So given C, find the probability that the student is left-handed. So what we have here is P, L, so this is your L, given that the student is curly-haired. Okay, see that after the word given is curly-haired, so curly-haired has to be at the back. Okay, so just use the formula PL intersect C over PC. Okay, what's in the back? So we just substitute the formula. 0.03 over PC is 0.15 equals to 0.2. Okay, next, what is the probability that a left-handed student also curly-haired? So this is quite a tricky question. So what we have here is also, that also. Okay, so we have a curly-haired. Let's just change the color here. Also, that also. So which one is at the back? Left-handed student, curly-haired. Okay, so that means dalam ramai-ramai left-handed student tu, how many curly-head students? So what we have here is P, C given L. Okay, is equals to PC intersect L over PL. So just substitute into the formula 0.013, 0.12 equals to 0.25. Okay, so that's it. Let's see the last example here for conditional probability. 30 mathematics professors out of 100 who are examined were found to be overweight. 10 of them had high blood pressures. So as you can see from the question, we can use the table. Okay, as I said, probability, you can represent what you have, the data that you have, the number of outcomes that you have, by using tree diagram or table, or one more is Venn diagram. Okay, so now let's do this by using table. Okay, here's our table. So we have professors who are examined were found to be overweight. So we have overweight, not overweight. Okay, so put that two events together, and then we have high blood pressures and no high blood pressures. So let's just fill in our table. 30 mathematics professor out of 100, so the total is 100, so here should be 100. 30 mathematics professor are overweight. Okay, so 30 should be here total. 10 of them had high blood pressure, so 10 had high blood pressure, so that means 20 don't have. Okay, so next one is only 4 of the professors who were not overweight had high blood pressure. So here is 4, and the rest you can find it by yourself. 100 minus 30, this one should be 70. 70 minus 4, this one should be 66. And you can find the rest of the total here, which is here is 14, here is 86. Okay, so we have our table. The question said find the probability that a mathematics professors who will not have high blood pressures, not have high blood pressures, if, okay, so keyword is if he is not overweight. So what we are going to find is P not have high blood pressure, that means H prime. Okay, given that, or if he is not overweight, so O prime here. So this is what we want to find. So by using the formula of conditional probability, we just have PH prime intersect O prime, follow the order. So what is in the back will be on the below as well. Okay, so now PH prime intersect O prime. So we have H prime. Why is this is O? This one should be W. Okay, let me just put this W prime, W prime, W prime, prime. Okay, so H intersect W prime. So you learn your table. So H prime W prime intersect is 66. Okay, equals to 66. But remember, you are finding a probability, so that will be 66 over 100. So probability of professor who are not overweight, so here will be 70. So 70 over 100. So simplify, you'll get 33 over 35. Okay, so that is one way to represent our data by using table, or you can just use the formula. Okay, alright, so let's continue. Okay, last one is independent event. So as I said here, we have independent event, which is an event which one outcome does not affect another outcome. So it is independent. Okay, so what we have here is the formula. PA intersect B is equals to PA multiplied by B. Where does this comes from? So let's take a look at the note here. From the probability for conditional events, you know that the formula is PA given B is equals to PA intersect B over PB. So if we rearrange this, we have PA intersect B, make this as our subject. We bring this to the other side, you have PA given B multiplied by PB. If A and B are independent, what does it mean by that? Say that outcome of one event does not affect another outcome. Okay, so this outcome of this event does not affect outcome of this one. So what we have here is PA given B is the same thing as PA. Okay, and PB given A is the same thing as PB. Okay, this thing here, this one at the back here, already happened. Okay, already happened. That means the outcome of this thing does not affect the outcome for this one. So that's why we consider PA given B is equals to PA if event A and B are independent. So from this formula here, since outcome of this does not affect outcome of this, so this one we will change to PA only. So that's why we have the formula for independent events PA intersect B is equals to PA multiplied by PB. Okay, so let's write that one more time. We have the formula from the conditional. PA given B is PA intersect B over PB. So if we rearrange, we have PA intersect B is equals to PA given B multiplied by PB. Okay, so since this is independent, if event A and B are independent, so outcome of B does not affect outcome of A, so that will be equals to PA dot PB. A intersect B. Okay, so that's where the formula for independent event comes from. Oops. Let's do that one more time. Okay, I hope you can see that. Okay, so let's just go straight to the example. 20. Two events A and B are independent. Given PA and PB, calculate PA intersect B. So this is very simple. PA multiplied by PB. So because the question like literally said two events A and B are independent, so we just multiply those two probability. 0.4 multiplied by 0.25. So here we have 0.1. Okay, next is PA union B. You know that if you have PA union B, there is no other way. Just use the formula. Okay, don't use PA plus PB only. If the question said the event is mutually exclusive, only you have to use PA plus PB. Other than that, we just stick with PA plus PB minus PA intersect B. Okay, remember this is a very important formula. Okay, please remember. So here we have 0.4 plus 0.25 minus the answer from A. So here we have 0.55. Okay, now let's take a look at example 21. So A, B, and C are three events such that A and B are independent. Okay, so what is given to us is A and B independent. Okay, A and C are mutually exclusive. A and C mutually exclusive. Okay, so from that info, what we know here is PA and PB. PA intersect PB intersect B is equals to PA multiplied by PB. Okay, whereas for A and C, which is mutually exclusive, we have PA union B is equals to PA plus PB. Okay, so that is what we have. So for the first question, PA union B, so straight away we have PA plus PB minus PA intersect B. Okay, A and B are independent. This is the only thing that we know. So we have PA is equals to 0.4, PB is 0.2, PA intersect B is 0.4 times 0.2. Okay, because we know that this is independent. So the formula will be PA multiplied by PB. So that will be 0.4 times 0.2. Okay, put that in your calculator, you should get 0.52. Okay, for question B, PC given B, so PC intersect B. Follow the order over by what is at the back, PB. Okay, so C intersect B. Do we have C intersect B? Yes, we do. PB intersect C is the same as PC intersect B, which is 0.1 over PB, which is 0.2, and here we have the answer 0.5. And the last one, PC given A prime. So use the formula for conditional, which is C intersect A prime over PA prime. So this one here, how are we going to find this? PC intersect A prime by using formula PC minus PC intersect A. Okay, this is for C only occurs, so you have to use the formula PC minus PC intersect A over by PA prime is 1 minus PA. But now we have PC. Okay, from the question we have PC 1 minus PA. We have the PA here is 0.4. So how about this one, PC intersect A? What we know is A and C are mutually exclusive. Since A and C are mutually exclusive, this is the formula. PA union B equals to PA plus B. Okay, why we don't have PA intersect B? Because your PA intersect C is equals to 0. Okay, because the two events cannot occur at the same time. Alright, so this will straight away become 0. And we substitute everything that we have. PC is 0.3 over 1 minus 0.4, and we'll have the answer 0.5. Okay, so let's see example 22. Something about problem solving here. A mathematics puzzle is given to 3 students. From the past experience, known that the probabilities and then Balkis and Chua will get the correct solution are 0.65, 0.6, 0.55. Okay, so let's put that into the probability. PA and then is equals to 0.65. PB for Balkis is equals to 0.60, and PC for Chua is 0.55. If 3 of them attempt to solve the puzzle, we are going to find the probability. Remember this? Remember pula. Make sure you know this without consulting each other. Okay, find the probability that the puzzle will be solved correctly by all of them. Okay, that means Anand, Balkis and Chua solve the puzzle correctly. So what we are going to find is actually PA intersect B intersect C. Is this an independent event? Yes or not? The question said if three of them attempt to solve the puzzle without consulting others. So we know that the outcomes of Anand solving the puzzle does not affect outcomes of Balkis solving the puzzle. The same thing happened to Balkis and Chua. Okay, the outcome of Balkis solving the puzzle does not affect outcome of Chua solving the puzzle, because the question said without consulting each other. So this is an independent event, so we just multiply everything together. PA multiplied by PB multiplied by PC, which you should get the answer 0.65, 0.6, 0.55, and that will be 0.2145. And last one, only one of them will get the correct solution. Only one. Okay, you know that if I said only A, you have to write PA intersect B prime. Okay, so how about only Anand? How are we going to write that? PA intersect Balkis prime, Chua prime. Okay, only one of them. So maybe Balkis will solve the puzzle. So let's put Balkis will solve the puzzle. Not Anand. Balkis, yes. Not Chua. Maybe Chua will solve the puzzle correctly. Not Anand. Not Chua. But yes to... not Balkis, but yes to Chua. So how are we going to do this? This one is multiply or plus will be plus. Okay, because the question said one of them. So either Anand or Balkis or Chua. So what you're going to do here is, because this is all the independent events, so you are going to multiply every probability that you have. 0.65. Here is 0.65. B prime. Okay, B prime is 0.4. Why? Because PB is 0.6. So your PB prime is 0.4. See here, this one is 0.55. 1 minus 0.55, we have 0.45. Okay, so fill in everything here, and we have to plus, and you'll get your final answer 0.289. Okay, last example, example 23. This one you can do it by yourself. This is the answer is 0.12, and this one is 0.58. Okay, so that's all for mutually exclusive, independent event, and also conditional event. So let's recap one more time. Mutually exclusive, the two events cannot occur at the same time. Okay, the two events cannot occur at the same time. So the formula, that means PA intersect B is equals to 0. So we have PA union B equals to PA plus PB. Okay, it comes from this formula. Since we know that this will be 0, so we are left with this formula for mutually exclusive. Independent events, one outcome does not affect another outcomes. So we have PA intersect B is equals to PA multiplied by PB. And we have conditional event, keyword is if, knowing, given, and so on. So this is the formula. The given part is always on the back here. Okay, alright, so that's all for this video. I'll see you guys in the next one.